specific heat calculations. Okay, specific heat is the amount of energy required to raise the temperature of 1 gram of substance by 1 degree Celsius. So it's basically how easy a substance heats up or cools down. The higher the specific heat of a substance, the more energy is required to heat it up. Okay, we're going to define these variables. Q is going to be the amount of thermal energy sorry, I didn't mean to turn that sideways on you. Energy released or absorbed by a system. And it's measured in joules. Now Q can be either negative or it can be positive. If it's negative, that means heat has been released. And if it's positive, heat has been absorbed. And we learned that in our last unit on thermochemistry. Okay, what's this CP? It stands for specific heat. And it is measured in joules per gram times degrees Celsius. Joules per gram times degrees Celsius. All right, then we've got M. We know M. We've seen that many times. This is going to be our mass. And then this is called delta, change in temperature. Okay, so change in temperature. And this is going to be in degrees Celsius. So how do I solve for this? Delta T equals the final temperature minus the initial temperature. All right, and we'll talk more about that later. Okay, so there's all our variables that we're going to be using, and now we're going to plug them in as we solve these different equations down here. Okay, determine the amount of thermal energy associated with 550 grams of water heating up from 10 degrees Celsius to 90 degrees Celsius. And it says the specific heat of water is 4.18. Okay, so again, we're going to solve. I've got Q equals specific heat times mass times delta T. All right, so what do we know? We know mass is 550 grams. We know specific heat is 4.18. And we know our temperature. So what was our final temperature? It was 90, and our initial temperature was 10. Final minus initial. Okay, so that's going to give us a temperature change of 80 degrees Celsius. All right, so we're solving Q because it says the amount of thermal energy. That's what determined the amount of thermal energy, which is our definition of Q. Okay, so Q equals whatever this is. So again, we're just plugging numbers into formulas, and we're ready to solve. Oops. Okay, so here we go. Escape. So we got 4.18 times 550 times 80. Enter, and there's our answer. We got 183,920 what? What do we measure Q in? Measured in joules. So we're going to put a J out there for joules. That is our answer. Okay, 183,920 joules, And yes, it's positive because we're heating this up. Let's look at a different one though. It says the specific heat of lead is 0.129. Find the amount of heat energy released when 703.8 grams of lead are cooled from 37.2 to 12.5. Okay, so on this one, we know the mass, we know the specific heat, and again, we know our starting and final temperature. So this is the initial temperature, and this is the final temperature. And this is going to make a difference on this one. Again, we're finding the heat energy released, which is the definition of Q. Q equals specific heat times mass times delta T. Okay, so on this one, we've got 0.129 times our mass, which is 703.8 grams, times our delta T. Now, here's where we're going to get that negative number because we're going to have 12.5 minus 37.2. Okay, let's do that first. So we're going to have 37.2, delete, I just did it wrong. 12.5 minus 37.2. Okay, there we're getting a negative number. Here's how we're going to have a negative Q. All right, because we're going to do 0.129 times 703.8 times negative 24.7. All right, this time it's a negative Q. Q equals negative 2,242.52. All right, that's how it becomes negative because it says heat released. So heat released is negative. This is where the negative comes in because it's final minus initial. All right, what if we're calculating for something else? Like on number 3, it says calculate the specific heat of a metal and determine its identity if 100 grams of it releases 45,000 joules of energy and has its temperature decrease from 200 to 100. Okay, so again, we've got initial temperature and we've got final temperature, and temperature is decreasing, okay, and we're releasing 45 joules of energy. So again, I'm going to write this out. Q equals Cp times my mass times my delta T. Okay. I'm calculating specific heat. This is what I don't know. This is my X. I do know Q because what's measured in joules? My thermal energy. And it says it's released. So that's how I know it's negative 4,500 joules. So there's my negative number times my mass, or my mass is on the other side, sorry. And then if I subtract 100, which is my final temperature, minus 200, obviously that's a negative 100. All right, so now I'm ready to solve. I've got negative 4,500, so I need to divide both sides by what? I got to get rid of this 100 and this negative 100. 100, negative 100. All right, those cancel each other out. So now I'm ready to put it in the calculator. I got control divide. Negative 4,500 on the top. On the bottom, I've got 100 times negative 100. All right, control enter. There's my answer. So my specific heat is 45 joules per grams degrees Celsius. Okay, that is my answer. And then it also says identify the metal. So we're going to go to our reference sheet and we're going to see some specific heats of some metals. And ours is 0.45. Notice iron is 0.44 or nickel's 0.44. So we can say for sure that this is either iron or nickel. So we're not exactly sure which one. So I would say this is either iron or nickel. Okay, let's do, oops, you can't see it, iron or nickel. All right, on the back page here, let's do one more together, and then you're on your own after this. All right, so right here, let's go through. Copper releases 14,500 joules. In order to cool it from 75 to 5 degrees Celsius, determine the mass of a piece of copper. And it says the specific heat of copper is 0.387. So we're ready to calculate again. Again, we've got Q equals mass, or you can do it either way. It doesn't matter. We've been doing specific heat times mass times delta T. So here we do know the Q. It says releases, so we know we've got negative 14,500 joules of energy. Our specific heat is 0.387. And then we don't know our mass. And then here we're going to subtract. So our final temperature, this is Ti, and this is Tf. So it's always final minus initial. So we're going to get negative 70 degrees Celsius right there. And you're ready to solve. So this time we don't know mass. So we're going to set it up the same way. I got to get mass by itself, so I need to get rid of these numbers here. I need to get rid of my specific heat and this negative 70, okay? So we're going to cancel those out. And then again, plug in your numbers. I got negative 14,500 on the top, divided by, oh, let's do it this way. I like it better. Control divide, negative 14,500. And then on the bottom, I got 3.387 times negative 70. And there's our answer, 535.25 grams. And there's your final answer. Okay, so I've given you examples of every type that you're going to see on here. So I need you to complete 5 through 13. 13 you don't have to solve, just explain. Give me an explanation about this. If you have any questions, let me know.